One of the things we've been talking about this morning is this thing about background leakage and the fact that we have got to change how we think about that. We've got to understand it better because that's a key part of where we're going to be going with those adaptive pathways. And so part of this innovation that we've got to see coming through is going to say, okay, how do we understand the leaks that we don't know about at the moment? And some of the technologies we're going to be looking at this afternoon are going to be helping us do that. How do we find those leaks that at the moment we're really struggling to find? And when you talk with the leakage manager, they go, that's not really important. I'm sure they're pretty small, they're pretty tiny. Actually, those leaks are now becoming increasingly important because we need to understand that background level of leakage. Okay, we need to have a far better handle on what's going on. And I've talked with water companies that are going, do you know what? We are literally there with our ALC. There's not really much more we can do with that. We've got to start bringing in new and better ways of doing stuff. So that's where we're going to be going. Welcome up here. What I'm going to do is I'm going to give you 8 minutes of speaking. I've got my phone down here, so I'll give you 8 minutes of speaking and then 4 minutes of questions, okay? And then if there's any time at the end, we'll have a quick open round session of questions, okay? So that's going to be the kind of format for it. It's going to be short and punchy like that. As they're speaking, get your questions in on Slido. I've got my tablet as well. I am multifunctional up here, so I'll be watching your questions come in, so we'll do those as well. But if you don't do any questions, don't worry, because I've got plenty. So we've talked a little bit about background leakage. Okay, and about the issues about how we get down and start to get that kind of understanding. And I really liked it when I was looking at your website. You have a great tagline on there, which effectively, and I'm going to paraphrase, finds the leaks other things can't. Okay, which was really good. And I think that to me is you know, I think if you stood up here 2-3 years ago, people would be going, well, I want to find the leaks that I can at the moment. But I think that we're having to push into these other areas. So I'm really interested in your solution. Bradley, over to you.
Thank you very much. Good afternoon, ladies and gentlemen. First of all, obviously Electroscan, we are a leak detection and pipe condition assessment company. And the technology that we use is focused electro leak location, or FEL for short. So basically, in simple terms, we emit an electrical current into water. So we do what basically you were told not to do when you were kids. As our probe is going through a pipe, obviously surcharged, we're acting under Ohm's law. And when we come across a defect in that pipe, we turn to Torricelli's law. So the easiest way to explain this is if you imagine a light bulb. When we come across a defect in that pipe, we measure how long that light bulb stayed on for, and we measure how bright that light bulb got. This enables us for the information to come back to our system, quantify the data, and we can actually give you an estimated defect flow rate in litres per second and litres per day. So a quick layout of how actually one of our scans will actually happen. As you can see here, this is our tethered solution. From a van, we also have a push rod system. And obviously, like I've said, as you can see, as the probe's going through the surcharge pipe, as it comes across a defect in that pipe, the electricity will escape, travel back through to our grounding stake, and come back to our voltage source, which is our van and our software. Some of our advantages for using, obviously, machine intelligent non-acoustic technology. We're not affected by ambient or street noise, high groundwater or low water pressures. And after a scan's been completed, we upload our scan via our Wi-Fi and our vans through T4S up to our Amazon Web Services cloud system, which then pushes it onto our critical H2O software. Our critical H2O software is the software that quantifies the data, and then it's pushed back to the client and the operators in the ground within 10 minutes or less. So here's one of the basic reports that you'll get. On the top left, you can see the defect count. So obviously this gives you the number of defects and the classifications of those defects. Next to that, you can see the total defect flow in litres per second and litres per day. Next to that, you can see the diameter and the distance, and below you can see the pipe defects that were picked up on the graphical display. So some questions that we get from clients that we've had in the UK and the EU. One, is it going to affect customers' houses when we put electrical current next to their house? No, it doesn't. The power that we actually put out of our probe is probably the same power as a pack of 6 AA batteries, and it will dissipate in less than half a metre. The other question we get asked is, do we get affected by electrical interference? Again, no, we don't. We actually done a trial. We went to Ginza Station in Tokyo. We actually done a 1,000-meter survey using one grounding source, and electrical interference was not detected. So when we want to talk about repeatability and things we're looking at for innovation, as you can see on the right-hand side, our probe is moving up and down a see-through pipe continuously. Each red dot is a defect in that pipe. Now, if you look to the left-hand side, you can see our graph is picking up each of those defects as it's going forward and backwards. And as we zoom into that scan after, you can see that using both the laws, defect 1, 2, 3, and 4 going forwards is the same as defect 4, 3, 2, and 1 going backwards. So obviously this gives Electroscan that unmatched data repeatability. So how do we achieve that 1 centimeter locational accuracy that we claim on our website? With our conductivity probe, we have a tri-electrode system. So as our center defect node emits that electrical current and starts spreading out, our forward and rear defect nodes catch that current and push it back towards the center, forming a flat disc. That gives us our 1 centimeter locational accuracy, and then gives us, obviously, like you see the results below. So obviously with this new approach, we actually can eliminate the variable of C in the hole, and we can now actually look at measuring the size of the hole instead. So I just want to quickly go through some of the products that we have, the specifications on all the products. You can come and see our booth afterwards in the break. We've got product catalogs and we can go through everything with you. We have the Delta, which is our tethered van system. We have a 1 kilometer cable on that, and we can handle pipe diameters from 150 to 1500 mil. That has a FEL probe on, CCTV, and an acoustic. The Trident is a push rod system with 120 meters of cable on, and has a FEL probe and just CCTV. Delta and Trident are currently being implemented into Anglian water with the help of James Hargrave, so thank you very much for that. And the 2 new products that we have brand new on the market is the Swordfish and Kingfisher. So the Swordfish and Kingfisher allows us to assess pipes now from 25 up to 75 mil. So now we're focusing on the customer side DMA level, accessing Atlas boxes. This was actually designed because we were actually asked by an employee at Thames Water if it was possible if we could make something like this. So that was actually the result. At the moment, around the world, we actually currently have a lot of major international projects either on the way or currently underway. We also have a lot of sewer stuff as well. Electroscan's recent awards. Last year in June 2021, Electroscan was awarded Top Product of 2021 by the Environment and Energy Leader. In November 2021, Electroscan won the Petronas Technology Challenge for inspection techniques of underground piping. And January this year, we were awarded Leak Detection Solution of the Year, 2nd time in a row through IoT. Thank you very much. That's the end of my presentation.
That was great on timing as well.
Thank you very much.
Thank you.
Thank you.
Thanks, Brad. That was really good. And I'm changing to calling you Brad now because I can see that I'm allowed to do that.
Yeah, that's fine.
So, Brad, a number of questions are coming while you've been speaking, but let's kind of start with that first one, is the UK water specific. Obviously, we take our hydrants, we bury them nicely underground. We have things like fixed jumpers on them, so sometimes it's really hard to get something. How do you get your device into the water column? What's the best way of doing that?
So we have a few access points that we can actually get into. Gate valves, air valves, hot taps, and predominantly through-bore hydrants. Obviously, it enables us to have direct access straight into the pipe. At the moment, we are experimenting with the normal standard hydrants, and obviously the American side have adapted their technology to actually access their fire hydrants. So it's just a case for us at the moment. We have a limited variance of what we can actually get into, which I would happily go through back at our booth. And it's just more of experimentation, seeing how we can adapt the technology.
And you know, what pipe materials are you finding this works best on? Are you going to say everything, or is there particular pipe materials where you recommend it for?
We will say everything, but our best material we work in is PVC. A lot of things we're getting from utilities now and subcontractors is that foul works best in PVC pipe. Now everyone says, you know, it's hard to find a leak in PVC pipe. At the moment, that's great for us because we've been benchmarked to find leaks in PVC pipe. So yeah, I'd say that's probably our best material that we look at.
And I can tell you right now that there's probably a dozen managers out there frantically emailing through going, I think I found something at the conference. Okay, PVC pipe, huge problem in the UK. I know it was in the States as well. Yeah, that's very, very interesting. For those that don't know, PVC pipe is a particular problem because when it was introduced as a wonder material. And it was put in with crowbars because you could, which puts stresses on the pipe, which can then fracture. It's really susceptible to UPVC, so they put a nice little pile of pipes by the side of the road ready to fit them, and the one on the top would get all the UV, and that would be the one that would fail in about 5-10 years down the line. So it is a huge issue in the UK, so I'm really interested in that. Just had a question about, obviously, when you're putting something down the pipe, you've got the delta, you know, the kind of disploys down there. Do you find that that causes sediment issues at all, or...?
No, so we've done turbidity tests, and obviously we've passed them in the past. Obviously, we're constantly assessing as we're scanning anyway, both with the Delta and the Trident. You know, we have done tests with Trident in the past where we start seeing tuberculation levels getting high, and obviously we then reassess and say, right, we're going to stop here and not go any further because we don't want to cause a pollution incident. And the same with Delta. Every test that we've done, we've had turbidity sensors in there. It's not actually picked up anything and caused any incidents. Touch wood, not yet.
And so, yeah, the bit, just wanted to kind of follow on from that. What's your model for deployment of this? So, because you've got to introduce something into the pipe, that's quite intrusive, and, you know, I think a lot of managers will be going, I can't run that out across my entire patch, okay? So I think there's a couple of models that will come off the top of my head, and you're going to go, okay, I'll do it for the bits that I know are worst. Yeah, I'll do it for my PVC pipe network where I'm worried about it. Or even I'll do it on a percentage of my DMA just to find out what my background leakage is and then scale that up across the entire DMA. What's your model that you're thinking of?
So we've been approached, obviously, like you said, about a percentage of a DMA, and said basically if we were to give you that area and investigate it, you know, what kind of results do you reckon we could get from that? So we've had that in the past. We've done service agreements. For example, our name Southern Water and the Government of Jersey. The Government of Jersey handed us last year 18 kilometres and literally just said, do half the island. That took us just over a month. And Southern Water, we've just completed a 51-kilometre survey, but that was for sewer, not for clean.
Brilliant. Thank you so much for that. Really interesting discussion. So your stand is there, isn't it? I saw you basically come in and just keep walking, I think. You're on the far side, aren't you? So there we go. I'm sure you get a load of people coming up and grabbing brochures on that one. Anybody with PVC is going to be beating a party. I want to
see at least one person take a baseball hat. No one's taken one yet.
Oh, seriously? There's baseball hats?
Yeah.
Oh, I'm going to be there. Right. Please, 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 look. They've taken time out from their busy days to come here. I'm sure they've had an excellent conference, but this is their businesses. This is what they're trying to do. Do take the time. If you've been listening to what's been said and things like that, and you want to have a chat with them, seek them out, go and find them, have a chat with them, find out what they're doing, and help these companies. Let's make leakage innovation in the UK a place where companies want to come to work. Yeah, where we attract the best in the world because people go, you know what, if you pitch in front of the UK water companies, they listen, they come and talk to us, and they help us develop solutions. So do come and have a chat with these people here. Thank you.